Earlier this year, Intel has finally released its latest HEDT platform based on Xeon Sapphire Rapid CPUs. Sharing the same socket with Xeon Scalable, this platform will have its own W790 chipset. With up to 56 cores, up to 8 DDR5 memory channels, and up to 112 PCI Express 5.0 CPU lanes, Intel hopefully learned on its past mistakes and finally released a competitive platform that can take on Ryzen Threadripper 5000 series. Because let's face it, Threadripper is the king of HEDT at this moment. This platform also has a big processor lineup, hopefully covering all kinds of HEDT needs of its potential customers. Because it's based on Xeon Scalable, it also uses Intel's latest 4-tile design for high core count CPUs. In this video I would like to give you an overview of this platform, tell you what I bought for myself, tell you about my overclocking adventures, and even game on it, though just a little bit. Let's begin. To understand the full importance of this platform, let's discuss previous HEDT platforms from Intel and AMD. If you do not want to listen, just use the timecode to jump to whatever part you like. When AMD released its 1000 and 2000 Ryzen Threadripper CPUs lineup, they have seriously crippled Intel HEDT market share. With 3000 series Threadripper, Intel was just not competitive anymore. They did attempt to compete with AMD with 3647 platform, but no, they couldn't. It was really hot and too expensive. And with 5000 Threadripper lineup with 64 cores and 8 memory channels, Intel just did not have anything to compete. AMD basically dominated the HEDT market at that point and slapped a huge price tag on 3000 and 5000 Threadripper series. Because AMD is your bro only when the market is competitive. Because if it's not, they can slap any price tag they like. They're really not any different from Intel. So the market, and me included, really wanted Intel to release a competitive response to this platform, and Intel finally delivered. To create this platform, Intel took its latest Xeon Scalable CPUs and adapted them to HEDT market. Interestingly, this platform has 2 CPU lineups, which we will discuss a little later in this video. And it also has its own chipset, W790, which we'll also discuss later. So what is interesting about these CPUs? First of all, it has the same Golden Cove core architecture, just like Intel uses on P cores in 1200 series. That's why these cores are expected to be really fast. They also have no E-cores. They are based on Intel 7 node, which is 10 nanometers. As I previously said, there are 2 types of CPU series on this platform, the 2400 and 3400. If you want to buy this platform, you should seriously consider which lineup is the right for you, because the difference is quite significant. Let's discuss 2400. They have up to 24 cores, 4 DDR5 memory channels, and 64 PCI Express 5.0 lanes. It has a monolithic die, just one huge silicon die, while 3400 has up to 56 cores, 8 DDR5 channels, and 112 PCI Express lanes. So more GPUs, more memory, more PCI Express. It's also based on a new tile design Intel uses for Xeon Scalable processors. Each of these tiles has 14 cores, 2 memory channels, and 28 PCI Express 5.0 lanes. And using the new EMIB interconnect, they are combined into one huge 56-core CPU. If you're just like me, you're reminded of a Ryzen 2000 and 1000 series, which used similar approach, which combined 4 dies under one CPU. So the new EMIB multi-die interconnect bridge fabric allows Intel to connect these 4 dies into one single CPU. So basically it's a new generation of mesh fabric between these dies. It's actually the same EMIB fabric for both die types, so you're getting it on any CPU you're buying in this lineup. But you might be asking yourself, how does this whole new 4-tile design works with NUMA? It's actually a very important question, and that was the first question I asked myself when I saw this new 4-tile design. And in terms of NUMA, it's a single CPU. So all tiles behave like a single processor, and it's really good because most apps do not support NUMA. And you would have a really bad time on a CPU that would consist of 4 NUMA domains. Though this processor is based on Xeon Scalable, all the accelerators are disabled. Intel doesn't want HEDT to compete with its Xeon Scalable lineup. If you want them, buy Xeon Scalable. But EMX and AVX512 instructions remain, so that's a good thing. So back to CPU lineup. As you can see, there's a huge number of CPUs starting from 6 cores. And those CPUs support full 2TB of RAM and 64 PCI Express lanes. Bear in mind, if you want overclocking, you need a CPU with X in its name. No X, no CPU or memory overclocking. You can also overclock the mesh fabric, and it basically improves everything. And on a monolithic die, you can expect better mesh overclocking. Because monolithic die, on a tile-based die, you can only overclock the mesh fabric multiplier up to 27. While the monolithic die can go much farther. Also bear in mind that 2400 supports only 4 GPUs, while 3400 supports 7. Now let's discuss motherboards. There are two types of motherboards for this platform. One designed for 3400 and the other designed for 2400 CPU series. The CPUs are compatible with any motherboard in W790 series, but you should get the proper motherboard to use its full potential. There are a whole lot of 7 motherboards for this platform as of making of this video. And I would not recommend buying 4 of them, so you're basically stuck with 3 motherboards. ASUS released 2 motherboards for this platform. One of them is W790 Ace and the second one is W790 Sage. This is for 2400 series CPUs with 4 memory channel and 64 PCI Express lanes. Though you can easily put a 3400 CPU in this motherboard, you will lose 4 memory channels and you will only have 64 CPU lanes. I strongly suggest you buy proper motherboard for your CPU series. This board is okay, I can't really complain. I bought this one for myself, and so later in the video we will discuss my adventures with this board. So W790 Sage is for 8-channel memory CPUs, the 3400 series. Compared to us, it uses 8 memory channels, more PCI Express lanes, more M.2s. CPU power delivery is much beefier. Look how huge it is, it's EATX, it's 12 by 13 inches. It's a really solid motherboard with good overclocking potential, and it even has APMI. It's embedded into the board, while on ACE, to enable APMI, you need a separate card. ASRock has only made one board, and it's designed for 2400 series CPUs with 4 memory channels. And on paper, it looks in almost every way better than ASUS Ace. It has better VRM, it has USB 4, it has more M.2s, 2 10GB Ethernet ports. I haven't tested it myself, but this board looks solid if you want to go 2400 series CPUs. Gigabyte and Supermicro has basically made server motherboards. You can see the limited VRM and cooling on the VRM, and I'm not even sure if you're allowed to overclock these processors on these boards. You put these boards in a server in like 4U chassis with a huge blower cooler with 10,000 RPM. Interestingly, the 8-channel Supermicro board is the only board with 16 memory slots. So in some cases you may want that. So basically right now you're stuck with ASUS and ASRock if you want to buy an overclockable CPU, because why not buy an overclockable CPU? Overclocking this platform is actually quite fun. All-core frequency on these processors is actually not that high, so after overclocking you can expect solid performance uplift for this platform. Interestingly, because it's very hard to route so many memory channels and PCI Express lanes, these boards use a lot of PCB layers, which really improves memory overclocking. Also, as you might expect, overclocking such CPUs results in enormous power draw. For example, this ASUS motherboard is supplied with 4 CPU 8 pins. When I say CPU, I mean don't put PCI Express 8 pin in here, it's CPU. Now let's discuss memory. You will need DDR5 server memory kits in order to run this platform. These are DDR5 ECC registered memory sticks from Kingston. You cannot install server DDR5 memory into a normal motherboard and vice versa because it's keyed differently. So you will need to purchase a separate memory kit for this platform. You can actually see that this memory module has an extra ECC memory die. If you buy kits based on Hynix A-die memory chips, you can really expect solid memory overclocking on this platform, which we will discuss a little later in this video. Now let's discuss W790 chipset, which is basically Z790 chipset just renamed. It's a solid chipset, there is really nothing bad about it. It supports Wi-Fi 6E, 2.5GB Ethernet, USB 20GB ports. It's really a solid choice, so they did the right thing using it here. Now let's discuss what I bought for myself to build this platform. And we will begin with the motherboard, which is ASUS W790 Ace. As already said, it's a motherboard for for 2400 series CPUs. The box contents is really nothing fancy. It has CPU frames, which we will discuss later, a Wi-Fi antenna, and a SATA cable. That's it. First of all, use a CEB form factor, which has the same dimensions as eATX. The hole locations that mount the motherboard to the case may be different. Haven't tested it yet, so it may be a problem for future me. As I already said, it's a board designed for 2400 series, only 4 memory channels and 64 CPU PCI Express lanes. 3400 series will work here, but I don't recommend you do that. All 64 PCI Express 5.0 lanes are present in here, but bear in mind if you populate all 5 PCI Express slots, the bottom 2 will only use by 8 configuration. 12 CPU power stages are hidden under this huge CPU heatsink. ASUS doesn't tell what power stages they use, and I haven't checked myself yet. This board has 4 8-pin CPU power connectors. I strongly suggest you use at least 2 of them, unless you're buying like a 6-core locked CPU. This board can run 2 power supplies simultaneously. If you do not plan to use 2 power supplies, just use the gray one that is not covered. Also, another 8-pin gray connector is PCI Express. It used to power the PCI Express lanes. If you plan to put a lot of PCI Express devices in those PCI Express lanes, you should definitely connect it. But if you plan to put only a single graphics card, you should be more than okay without connecting it. The board has 2 M.2 slots, both are connected to chipset lanes and have, I would call them, half-decent radiators on top of them. An M.2 mounting mechanism doesn't use screws, which is a really good thing in my opinion. For the front panel, there's one Type-C 20 gigabit port, additional USB 3.0 ports, 4 SATA ports for SATA devices, and these 3 connectors that mostly present on server boards. These are slim SAS connectors, though you will need a proper cable for each of them. The left one is 4 PCI Express version 4 lanes, the middle one is 4 SATA ports or additional 4 PCI Express lanes, the right one is 4 PCI Express 3.0 lanes. There's a postcode indicator on the bottom of the board with some buttons that really help overclocking, and they're really useful when overclocking RAM or CPU. Integrated sound is ALC1220. It's a decent integrated sound, really nothing bad about it. On the back panel there are 8 2.0 ports, I don't know why this many, 4 10 gigabit USB, 1 20 gigabit USB, 10 gigabit Ethernet, and 2.5 gigabit Ethernet. So this radiator over here actually cools down the Ethernet chip and not the VRM. To pair with this motherboard, I got myself a Xeon W5-2455X, a cheapest overclockable 12-core CPU. There are cheaper options, but I really wanted to try overclocking, so here we go. 2400 means monolithic die under the heat spreader. Box contents is the manual, the frame for the CPU, and a way to show everyone how much money you spend on this platform. The CPU size is huge. If you haven't seen server CPUs, you might be surprised how big it is. Also, this generation the CPU is soldered to the heat spreader, which is really good for thermal performance. So let's see the socket itself. It's ridiculously huge, and it's also covered by default, so you wouldn't break it because it's very fragile. Just look how enormously huge it is. 4677 is the pin count on this socket. That's why it's so huge. Let's compare the size of the CPU with some other CPUs. Despite the fact that 4677 has 1,000 more contact pins in the socket, the CPU size difference with 3647 is actually quite minor. The heat spreader got noticeably bigger, so it should improve on heat dissipation. And the biggest difference is when you compare it to a desktop CPU, which is like 3 times smaller. Because of so many cores, PCI Express lanes, memory channels, you need a lot of pins to route that to the motherboard. That's why you have a huge silicon die and a lot of socket pins. Here's another angle for you to see the size difference of these CPUs. Now, you might be wondering, how do I put the CPU in the socket? Because there's obviously no mechanism to hold it in there. And the answer is, the cooling solution holds the CPU in the socket. For my previous 3647 platform, I used this Nactio cooling solution. It's not compatible with the socket out of the box, so I purchased this mounting kit from Newegg. It has everything included to unscrew the previous mount and screw this new mount for 4677. And by everything, I mean like everything, including accessories required to unscrew it from the previous socket, which I have lost, which is a big thumbs up to Nactio for that. You can actually save money by purchasing a used cooling solution and just buying a mounting kit for it. Because of the huge die size and soldered heat spreader, even air cooler allows you to overclock your CPU quite far. Obviously, a custom water cooling would get you much farther in your overclocking attempts, but still, this is a very good solution. Yes, I did clean up the contact surface. After that, you align the triangle on the CPU with the triangle on the contact frame, and then you just mount the CPU into the contact frame. It's not a very easy process, at least it wasn't easy for me, and I have touched the CPU in places no fingers should touch. That's why I have made sure I cleaned it up with some alcohol to make sure there's no fingerprints left on the contact pads. That actually may prevent the CPU from contacting the pins, and some of your memory channels or PCI Express lanes may just not work. So if you touch the CPU, make sure it's cleaned before installation. Obviously, I'm not talking about the heat spreader here. Next step is applying thermal compound, and because the heat spreader is huge, you want to apply a lot. You can use X or any other method you like to apply the thermal compound, just make sure the entire heat spreader is evenly covered. I'm using the good old method of X with dots, but you may use anything you like as long as it's properly covered. And as you can see, I'm not doing a really good job of it, but it works, so if it's stupid by working, it ain't stupid. And then you just attach the frame to the cooling solution, and it will click on all four sides, and that's it. It's ready to be installed. If you touch the other side of the CPU, now would be the good time to clean it with alcohol. Next step, installing it on the motherboard. Find the triangle again and align it with the triangle on the motherboard, and just put it in. And now the slightly tricky part. Those things on top of screwing nuts are the anti-tilt wires. Once you lock them in place, the CPU is locked in place. I suggest you screw each nut on every side just a little bit until you feel some tension, and then continue to screw them in until you feel at least, well, moderate tension, because you don't want to overscrew it, because that may damage the socket pins. Next step is installing the memory. Use motherboard memory population table to make sure you're installing it into the right places. It's important because if you just install everything on one side, you will have only 2 memory channels. Slot 2 and 4 on both sides will ensure you will have 4-channel memory. DDR5 memory gets really hot, especially if you overclock it. If your memory kit doesn't have pre-installed heat spreader, you should definitely get one and install it yourself. Trust me, if you don't install heat spreaders and overclock your RAM, you're doomed to have a lot of blue screens. I've used some very decent freeze mode DDR5 heat spreaders that I bought from AliExpress. The link will be in the description. The BIOS is classical looking. It's just like any server motherboard BIOS you may have seen. If you never used such BIOS before and used to graphical EUFI interfaces with mouse support, it may take you a little time to get used to, but it's actually very easy to navigate. This motherboard has full overclocking support of memory, CPU. You can basically overclock anything. Everything is available. So if you want to go and overclock the living hell out of your CPU, you will be able to do that here. Otherwise, it's just a normal BIOS interface. It even supports profiles, so you can save your overclock settings to different profiles and load them after. I actually didn't expect that, and I was pleasantly surprised. Now let's talk a little more about the CPU. As I already said, it's 12-core overclockable Xeon processor. W5-2455X. It's the cheapest one you can get if you want to overclock it, and I think it's not worth buying this platform if you do not plan to overclock it. What's the fun in that? Unless of course you're doing some important work on your platform and you need stability, and whatever software you're using, it's not CPU dependable. Let's run Cinebench and see what this 12-core CPU is capable in stock. The all-core frequency of this CPU is 3.9 GHz, so it's not really getting some earth-shattering results. In fact, it loses to 1300K because it's 14 cores, and even those E-cores are actually pretty decent cores. And with higher clocks, it just destroys this CPU in stock. It's nothing unexpected since you're buying this CPU for a lot of CPU lanes and memory channels, and CPU performance may not be even important for you. I've actually spent a few days playing with this platform, overclocking cores, overclocking memory, and stumbled upon a very weird problem. The DRAM command rate in BIOS is only properly working in auto. If you set anything else in there, the system will not boot up with a postcode of 29. And that really prevents you from overclocking RAM, because you kinda depend on what the motherboard will just set there in auto. In my case, it's command rate 1, and I cannot switch to command rate 2 to overclock my RAM closer to 7000. So I was stuck with 600 MHz with command rate 1. I already made a ticket to ASUS tech support about this, so hopefully it will get fixed somewhere, maybe in the future, but right now 600 MHz is the top I can squeeze out of my memory kit. By default, the mesh is X24, but you can get it to X28 almost without touching the voltage. It really improves the performance of basically everything, so overclocking mesh is very important. Sorry for the bad quality, I've pulled these out of my screen recordings, which were done at really bad quality. Now let's discuss CPU overclocking. Here's an example. This CPU is running at 1.3 volts on 4.9 GHz on all cores, and it's drawing 350 watts. That's basically the limit for this cooling solution. In the end, I managed to squeeze 5 GHz and it was drawing even a little more, and it was basically almost throttling. But still, I managed to run all the tests using 5 GHz. And on that frequency, it can finally defeat in multi-core performance a 13600K. In terms of single-core performance, we're actually really close. Obviously, each CPU is different, and they reach different frequencies on different voltages, but you can get a rough idea how much performance you can squeeze out of every core on this platform. Let's also run CPU-Z benchmark test. Comparing to 16-core Ryzen, you can see it can almost compete with it. It's almost on the same level. Obviously, if you're just gaming and not doing anything fancy, you should get Ryzen or just a core processor. You don't need this platform. This is actually for those who need to plug in multiple graphics cards and do all kinds of things that actually work related. Obviously, I had to game on it, so I took my computer I built with 13700K and 4080 and compared its gaming performance with the same 4080 with this platform. Understand this. This is a rough gaming test with only 3 games, full HD settings, high graphics settings, not ultra, because we want to be CPU limited, not graphics card limited. My rig, I used my 4080 gaming OC. For the Xeon, I used this 4080 Aero, which I had lying around for another build, because disassembling your build sucks, and this is just a beautiful graphics card for a great white build. All 3 games run in 3 configuration on my 13700K 4080 build against a Xeon with hyper-threading on and hyper-threading off. You might be wondering why, but actually a lot of scenarios, when you disable hyper-threading, the game performance increases. It's actually the same thing with some apps. If they just don't like many cores and prefer less cores with more performance, disabling hyper-threading really helps. And as you can see in Baldur's Gate, it does help. Obviously, the performance of W5-2455X is nowhere near 13700K, and you're not getting silky smooth gameplay experience on this CPU, even when running at 5 GHz on all cores. The game just doesn't utilize that many cores, and it prefers less but more performant cores than more but less performant cores. And disabling hyper-threading actually helps a lot. The FPS increase, especially 0.1%, is very high, though still not enough to comfortably play this game. If you're wondering why it's 5.3 GHz all the time on the left table and not the same thing on the both right tables, it's just an MSI Afterburner issue. I had to pull the core frequencies from HW info, that's why they look weird. Actually, in reality, it's the same thing for both tables, so don't worry about it. Next game is Cyberpunk, and as you can see, it utilizes a lot more cores. It's actually doing really great. This is before the next generation patch, so these results will be very different once I rerun the tests in future videos, but you can see the results. This game, it's actually a lot closer to the 13700K. So if you do some 3D modeling at day and play Cyberpunk at night, you're actually gonna get a pretty decent performance out of this CPU. And by disabling hyper-threading, you can actually squeeze even more, coming very close to stock 13700K. This game is Tiny Tina's Wonderlands, and there are also some issues with 0.1% lows on 13700K, so I suggest you don't look at those and just look at average FPS. And you can see the Xeon is actually winning in this game, which is a lot surprising for me. I do plan to make a separate gaming video on this CPU. Hopefully I can overclock RAM much higher, fix the command rate issue, hopefully overclock the mesh a little more, and maybe even CPU cores. Thumbs up if you like that idea, and feel free to leave a comment which games you want to get tested. As you can see, some gaming results may be very surprising. So what's the conclusion of this video? This is a very interesting new platform from Intel that will compete with 5000 Ryzen Threadrippers. It's obviously a platform for those who do some actual work on it, but you can actually squeeze some decent gaming performance out of it. Obviously it's more expensive than desktops, but that's what you get when you get to professional world. And HEDT platforms were never cheap to begin with. I think 5000 Threadripper series has finally got a good competitor on the market, but when 7000 Threadripper comes later this year, I hope it's not gonna destroy this platform that horribly. Thank you for watching this video. As I understand, English is not my native language, so I did the best I could. Thumbs up if you liked the video, and please subscribe for future content which I plan to release.